Welcome, everyone, and thanks for joining early. We'll get started at the top of the hour. Hello, everyone. We'll begin in about a minute. Thank you for your patience as we wait for the remaining people to trickle their way in. Hello, everyone. Thanks for joining, and welcome to our webinar, Code Coverage, Your Secret Weapon for Code Reliability and Developer Productivity. This is an often used capability within SonarQube and is extremely useful part of understanding the quality of your code base. Olivier and Anirban, our presenters today, will talk you through what code coverage is, why it matters, and how to effectively use it in SonarQube to manage your branches and pull requests to make sure your code base is always production ready. I'm Robert Curley, Product Marketing Manager for SonarQube Server. I'm your moderator for this webinar today. Olivier Korach, Head of EMEA APJ Technical Advisory Team here at Sonar, and Anirban Chatterjee, Senior Director of Product Marketing, are your presenters. Before I introduce Olivier and Anirban, please allow me to quickly go over a few housekeeping essentials. The session will last about 45 minutes, including time at the end for Q&A. We invite you to submit your questions at any time during the webinar via the Q&A box in Zoom. Please do not submit questions in a Zoom chat. This is very important because we're not monitoring the chat and we'll only be monitoring the Q&A area in Zoom for your questions. We also have a panelist today, Denis Troyer. Sorry, my French is terrible, so I'm going to always mess up his last name. Anyway, Denis and I will be answering your questions live during the webinar in that Q&A area. So feel free to submit your questions anytime throughout the webinar. You don't have to wait until the Q&A session at the end. The session will be recorded, and we will email you a link to the recording in a few days. We don't provide the slides. I know people will ask, but we don't. You have a recording. You can always refer to the recording that we send out. Links to resources will be provided in the chat section during the Zoom or in the Zoom area, the chat area. During the presentation, so keep an eye out for those. And we'll also send you information on all those resource links later as well. So if you miss it, don't worry. And then finally, at the end, we'll have a short survey that'll appear. This is something that we really appreciate your feedback. It helps us focus future webinars to suit your interests. And so we really appreciate your participation there. All right. Without further ado, I'd like to introduce you today to our presenters. And as I mentioned, Olivier Korach, is presenting. He's a seasoned software industry professional with over 30 years of experience. He started his career as a developer in the telecom industry at HP, then moved to customer-facing positions in technical pre-sales and technical account management. And as I said before, At Sonar, he is the leading EMEA and APJ technical advisory team, the leader of the team. And that team helps customers maximize the value they get from Sonar, from the Sonar ecosystem. Anirban Chatterjee is a product marketing leader for code quality solutions here at Sonar. He started his career over 20 years ago as software developer at IBM and has since worked for various startups in the enterprise IT software space. At Sonar, Anirban is focused on helping companies boost the value of their software assets so they grow their businesses. Okay. And you guys are really in for a treat. Olivier and Anirban are both very knowledgeable on this topic, and they're going to dive really deep today. So without further ado, Olivier and Anirban, over to you.
Thank you, Robert. I'm going to go ahead and kick us off, and I appreciate the warm introduction. This is a topic that is not a new topic at all. It's something that is very prevalent in the software development industry, as all of you, I'm sure, are aware. But it's something that I think is getting some renewed interest in the industry, just because of increasing attention to code quality, increasing attention to regulatory requirements and compliance and things of that nature. And so it's a good opportunity for us to level set on why code coverage is important and what are some of the tools that we have available to us to measure it, track it, and improve it in our code bases. We're going to start with a brief overview of just what code coverage is and why you would track it. This might be known information to many of you, but it's good, I think, for us to level set the conversation there and just get on the same page as to what code coverage is intended to be and the functions intended to serve. We'll next go into how code coverage measurement works, and we'll use SonarQube as an example of this. And Olivier is going to actually give you a really good demonstration of how we pull in the coverage data and visualize it for you, so you can use it to not only see what kind of coverage you have in your code base, but how to focus your attention on where you need to make changes and improve code coverage. We'll give some customer examples. And then finally, as Robert mentioned, there is a Q&A portion to this webinar. So we encourage any of you who have questions as we go through to go ahead and open the Q&A panel in Zoom and put those questions there. All right, next slide, please. Before we get into the content, there are a couple of poll questions that we'd like to put in front of you. And you should have controls popping up on your screen that allows you to respond to the questions. We're mainly trying to ask for this question: do you track code coverage today? What are you actually committed to as an organization in terms of code coverage tracking? Are you tracking it in Sonar? Are you using it in a different tool? Are you not tracking it, but you'd actually like to move towards tracking, and that's why you're in this webinar? Or do you just really not see a need today in your organization to track code coverage? I see responses are already coming in, so we'll give it another minute or so. Okay, great. It looks like the majority of you in the webinar are actually using Sonar to measure and track your code coverage, which is great news. And then there's a portion of you, about 16%, that are using a different tool for that. This could be an opportunity for you to bring that data, continue to use that tool, obviously, but bring that data into Sonar. And there's about a third of you who are curious about it and would like to learn more. And so maybe that's why you're here. So really glad to have you. We have a second poll question. And that question is, how do you use your code coverage measurements? Like, how is your organization actually using the data? Are you using it to maintain your code quality? Are you using it to comply with any company mandates you have, to comply with regulations, to detect regressions in function as you make code changes? Or, you answered no before, you're going to answer no now. You're actually measuring code coverage. We'll give it a minute or so for the answers to roll in. Okay, great. We have our results, and it seems like almost 3/4 of you, have the purest intention possible because you really just want to make sure that your code is high quality. You're not being forced to do it due to a regulation or a mandate or some compliance requirement. You genuinely just want to make sure your code is high quality, which is great. A third of you are doing it, the first may also be true for you, but the requirement is probably being driven by a company mandate. About 13% of you are complying with the regulations, and about another third of you are looking at functional regression testing to make sure that you're not regressing any functionality as you introduce new code. So this is great data. Thank you for sharing it. Hopefully you found it as interesting as we do. Okay, let's move forward now and start talking about code coverage. And as I mentioned before, many of you, as the poll results show, are aware of what code coverage is, but just to level set, when we talk about code coverage here at Sonar during this event, we're basically talking about a measurement of the percentage of a code base that is being exercised by automated testing. This is a critical thing to measure because it helps you gauge the effectiveness of the testing efforts you have that your developers are deploying within your code base. That helps you maintain software quality and reliability, which, as you all have told us, is one of the big drivers for measuring code coverage in the first place. And this is because thoroughly tested code is allowing you to update more confidently and avoid regression, because failing tests can actually very quickly identify issues and prevent functions from stopping, failing to function or failing to provide continued reliability for users. So these are really, really important things to keep in mind as you are developing code coverage. Next slide, please. What are the key benefits here? So again, this is probably not new information for many of you, but there are a number of key reasons why organizations are choosing now more than ever to focus even more on measuring code coverage. Automated testing, right? If you have these code coverage testing, regimes written up, you can trigger automated execution of these tests as part of the build process. This means that when you have high coverage, the build process is actually verifying your code for you automatically. So there's not really a need for manual testing and manual analysis of the tests to make sure that you're not regressing functionality as you push new features into the field. This also obviously helps you with early bug detection, which overall reduces your risk envelope as you are developing and deploying code. Avoiding regression is another key factor that we discussed, and it also means that you can easily maintain your code. If your code is more testable, if your code is written with testability in mind, this means that the code is also easier to maintain, not only for you, but for anybody else who has to jump into your code base to make changes or to fix things as they come up. Next slide. Thank you. Olivier is going to go into this in much more detail during his portion of the presentation, but just to give an overview of how we are measuring code coverage, there's three key metrics that we're generally looking at. The first one is line coverage. On a line-by-line basis, what percentage of the lines of code is being executed by your automated testing? The second factor here is condition coverage, which is mainly looking at branches and conditional statements that can follow multiple paths through your code base. Those also need to be individually exercised by tests to make sure that you're covering every possible execution path in your code as you're running these automated testing and automating them to run as part of the build process. And the overall coverage metrics that we calculate, that your tools calculate and pass into Sonar and that we display for you, are basically a combination of these two factors. And so we'll talk more about that in Olivier's portion of the presentation when he actually shows you how this looks. So what are some of the challenges that exist? Like what are some of the issues that can arise as you try to run these tests, collect this coverage data, and show this coverage data within your team and within your stakeholders? Well, there could be a lack of visibility across the board, right? If you don't have a centralized view of code coverage metrics across all the different projects and all the different applications and languages that you manage, it's going to become difficult to identify potential gaps in coverage that you might need to go address. This would then lead to inefficient bug detection, right? Because if you have fragmented coverage of code across your code base, it's going to make it harder for you to identify issues in your code, which will then make it slower to resolve those issues before they make it into production. Poor integration with DevOps platforms could actually make it harder to automate the code analysis. So if your DevOps platform doesn't have an easy way for you to integrate the automated testing, to kick it off, to pull in the results, to show those results, that is going to make it more difficult to report on it and then bubble up the issues that may arise if code coverage is not where we need to be as an organization. There could be a reporting or a compliance burden, and regulations or downstream customers you have may require that any software that you are creating or delivering needs to be covered to a certain degree by testing. And so visibility obviously is a very important piece of that equation to make sure that you are satisfying that requirement being placed on you by an external or third party or a regulatory body that requires a certain level of coverage for your code. And finally, there could be data silos, right? If you have different languages that you're responsible for, each language could have an individual set of tools that are used to measure the coverage in that language. And so that can create data silos of coverage that will make it more difficult for you to get an overall picture of coverage across your entire code base unless you're aggregating that somehow. And so next slide, please. This is where SonarQube can come in and add value because SonarQube is providing a centralized hub that integrates not only static code analysis results, but also the code coverage results from across all of the tools that you may have deployed within your code base across multiple teams, multiple languages, multiple projects, so that you have a single unified view at whatever level you need it to be to show you what your code coverage attainments are across your entire code base. This will then give you good visibility into where you need to focus to improve code coverage if you choose to. It'll also potentially allow you to use pass-fail metrics to make sure that a build cannot progress unless some minimum clip level of coverage is attained by the project. So what SonarQube is going to allow you to do is have actionable insights through granular levels of feedback, not only on the line-by-line level, but just across on the project level, so you can see not only where your code coverage gaps are, but within each individual file, what are the execution pathways that are in danger of being missed by automated testing. You can also track how the coverage is trending over time. So if you're trying to meet a company mandate to improve code coverage, or as a team you've decided you want to improve your code coverage, SonarQube is going to allow you to track your coverage stats over time, so you can see that improvement as you implement it. We also seamlessly integrate with CI/CD pipelines, as many of you know, which makes it really easy not only to automate the analysis and the coverage data collection, but also the integration of the coverage data into SonarQube so that you can see it as part of the build process. And finally, we can create reporting on this for you. So if we are aggregating the data from all of the tools in your code base for that measure code coverage, we can create reports based on that and show you what the coverage attainment is across your entire code base. And you can structure those reports however you like and share them with whoever needs to see them. Next slide, please. Why does this matter? So as we've mentioned a couple of times already, higher code coverage, we strongly believe it helps you identify bugs earlier in the development cycle. Occasionally, we hear from developers who tell us that, they work for organizations that maybe are looking at this a little bit differently. Sometimes if the right goals are not set for the team, it can be seen as a burden to increase potentially ineffective code coverage in a team. So it's really important to not only look at code coverage as a tool to improve code quality, but to use it to make informed decisions on where to focus resources to make sure that coverage is being increased in an intelligent way. Because if you look at the next slide, doing it in an unintelligent way, just solving for code coverage just to solve for code coverage is not actually going to make your code any safer or more reliable, because you're not really focusing on the right thing, which is to exercise the edge cases and the cases where a data could follow an unexpected path to make sure that you're catching problems that may only occur, once in a blue moon. But it is only one piece of the picture. You also have to look at things like code smells, security vulnerabilities, and other issues that might arise from the stack analysis that Sonar does alongside the code coverage metrics that we're helping you measure here. All right, I'm going to pass the baton now over to Olivier, who's going to go over more details on how you actually do this in SonarQube, as well as show you live in the product how it actually looks. Olivier, over to you.
Thank you, Anirban. So let's dive now deeper in how to achieve everything that was nicely presented so far. So first of all, to get code coverage in SonarQube, you need to run some sort of pipeline. Of course, depending on the different typology of projects, the pipelines may be slightly different, but there's a recurring pattern. Typically, you start by checking out the code. You build it most of the time. Then you will run tests, and this stage will produce unit tests report and code coverage report. And finally, you will run the scan phase, which means run the scanner, analyze the code for bugs, vulnerabilities, and the likes, but also absorb the reports that were generated during the test phase. It's quite important to understand for those who are, let's say, starting. For those who are already doing it for SonarQube, it might be obvious, but that SonarQube will not run your test and will not produce coverage out of the blue. Really, SonarQube and the scanners in particular are only in charge of absorbing test coverage that are generated by test tools that you would have to run before. Also, what's important is that there's two concepts around testing that are sometimes a little bit confused. It's when you run unit tests, you may produce two types of reports, and if you want to have the entire vision on what you're doing, you should generate both. The first type of report is the unit test report, which basically only gives a summary of all the tests that you run, those tests that passed, those tests that failed, those tests that skipped, etc., with the details of each step, each test, but you only get the big picture, okay? It's only a list of tests with the outcome. There's a second report that, despite the unit test report being important, there's a second report that is way more important for SonarQube and in general to manage and improve your quality, is the coverage report. This is typically much longer report because they will provide a line by line or condition by condition. Anirban already kind of uncovered a little bit the topic, but item by item report of each piece of code in your code base, in your project. And therefore, you can imagine that it's a much bigger report than the unit test report. But this one is really important because it will provide a very granular reporting and vision of what are the areas of the code that are well tested, well covered by tests, and what are the areas of the code that are not. You can run 1,000 different unit tests and do not realizing that all those 1,000 tests, they always cover the same area of the code, which is really a little bit inefficient. Thanks to the coverage, you will see how good are your tests and how well they exercise a maximum part of your code base. That said, now let's look into how this works in in SonarQube itself. So for this demo, I will use a simple project. It's a Java Maven project, but actually it makes very little importance. It's a simple class with a simple method here that computes something really relatively uninteresting. What matters is the coverage that's that's produced around this class. And I have a second test class that performs test on this production class. So this is the production code, coverage metrics, and this is the test code that will, as you can see, will invoke the function that's defined in the production code with a certain number of value and verify that the outcome of the call to this function is the expected value. Okay. So my tests are defined. I have 3 of them. And if I were to build and analyze my code after running the test in SonarQube, I would get something like that. So it's the same project here. I would go to the main branch. Okay. I get a coverage report, and on that particular cases, my code is extremely well tested. I get 100% code coverage. Okay. So if I go to that particular class that I was showing you, I can see that I have marker all green everywhere, which is a signal that everything is perfectly tested. You may notice that, by the way, that there are plenty of lines that have without marker. This can be a little bit surprising when you start with coverage, but be aware that in your code, there are plenty of lines of code that do not generate executable code, like a package declaration, obviously like comments, but also braces, etc. And the coverage tool will exclude those lines from the coverage report, and therefore the coverage is only computed on the useful lines, I would say, that will generate executable code. This project has been analyzed in a in a couple of different branches. And for example, so on this particular case, if I go to the code and I looked at the test, I indeed run three tests on that particular class, which ensure that I have everything covered on all the possible cases for that particular function. But I've created other branches where I have only partial coverage. If you look at the coverage on this branch of code, I only have 85.7% of code coverage. And if I look at the same class that is tested, I see that I have a barber pole mentioned here. It's typically a line that is only partially covered. And that's where the distinction between line coverage and condition coverage enters into play. Whenever you have a conditional statement in a piece of code, there's two branches of execution, two branches of execution, and even potentially more than two conditions. You have to make sure in that particular case that you run the test in the case where the condition I different from 0 is true, in which case you will enter the if block, which is the case here because we see the line k equal 1 is covered, and the case where I equals 0, where the if block will be skipped because not going through that block may have a special effect on the rest of the code. So this branch is not this branch of code with the test as they are defined is not completely covered. And why is that? Because if you look at the tests that are implemented on that branch, there's only one test with value 1, which is insufficient to cover all the cases. I have a different branch that has also different coverage here. It's 71%. Why is that? The situation in that case is a little bit different. I've only tested with the value I equals 0, which means the block where k is assigned the value 1 is skipped. And because of that, this line is partially covered. There's two possible execution paths, and I've tested only one. And because I've tested the execution path that will skip the if block, this line of code is not covered by the test. Okay. Then, yeah, I said, okay, there's branch of execution here, or flow of execution, but actually a condition is not exactly a branch of execution. It's the number of possible Boolean combination on the condition here. I have another example of this, a variation of this project where you can see here there are two tests, two Booleans in these conditions. So actually, to have a perfect coverage on this statement, I would need to test the case I different from 0 and j square superior to 100, I equals 0 and j square superior to 100, and vice versa. That's 4 possible conditions. And then in that particular case, I've only created 3 tests that we cover 3 out of 4 conditions. So I still don't get maximum code coverage. The next thing I wanted to show is how we spoke about line coverage and condition coverage. So this is stated in the measure section. In the coverage section, you have your overall coverage. This overall coverage is computed from a combination of line coverage. In that particular case, there's 5 lines in my code and they are all covered. I have 0 uncovered, so my line coverage is 100%. and the conditions in that particular piece of code. I have only one area where I have a conditional statement with 4 possible conditions, and 1 out of 4 that has not been tested. So my condition coverage is 75%. The overall coverage is the combination of the two. So it's total number of line covered 5 plus covered condition 3, 5 plus 3 divided by 5 plus 4. So that should be 88.9%. The only other thing that I wanted to mention is I spoke about the difference between unit test report and coverage report. Everything we looked at so far in this demo is about coverage, but you also have unit test reports here in your in the measure section. So you don't have the total number of tests, but you can see the tests that were executed in error, in failure, or skipped, and the test success. All these are metrics that, for example, you can use in your quality gate to enforce a certain number of quality. So zero errors, 0 failures, 0 skipped, or 100% success could be a quality gate conditions. I will use another branch that's, I think it's in partial coverage. Let me see. Sorry, I'm a bit lost. Yes. So in the coverage section, this one is interesting because as you can see, oh no, not either. I had one branch where I have a test that was executed in failure, but I don't find it anymore. So typically, if you have a unit test that fails for some reason, because the outcome of that test is not the expected one, you would get a non-zero number in failures, or non-zero number if in errors if the test would not execute as expected. Okay, but I don't know. I lost it. I can't remember which branch it is. So we have seen now the essence of coverage across a different situation. I wanted to show you also something else. Let me see. Yeah, I will go to a project. So one thing that Anirban mentioned is that having an interesting snapshot of your coverage at a given point in time is interesting. But one of the value that SonarQube is also providing is to show some insight on the evolution of your coverage and the efforts that you are doing over time. So you can see this evolution. That's an interesting project. This is a project that until April or May 2024 had 0 coverage. Probably there was no practice of code coverage. And then the development team started implementing coverage. So you can see that from starting May 17th, the coverage started to increase. It's relatively common that the first percentage of code coverage are gained relatively easily. But some of you mentioned the importance of maintaining quality. And when you reach this plateau around, it depends of your maturity and the testability of your code, but around 70 to 80%, it's also important to see that you maintain the coverage or you slightly increase over time, even when you're already high, because every 1 percentage point to gain in terms of coverage when you are reaching a higher number is getting more difficult. So it's important to maintain. The other thing I wanted to show you is tracking where your coverage is insufficient. So on this project, there's 76% code coverage. When you click on the coverage, you will immediately have a breakdown of the files in your repository that have the lowest code coverage, and you can explore what are the area of your code that are not properly covered. And typically this function is probably not tested, so it's all red. So it allows you to easily spot where you should focus your next effort to further improve the coverage of your code. There's another presentation that some customers like to see is this tree map, so you can drill down to spot easily, and you can find again the same sensor.py file in that particular case, to drill down directory by directory into the area of your project that have the lowest coverage to improve that coverage. All right. Last thing I wanted to show you, back to my initial demo project, is how do I manage when I have a project that is composed of multiple languages. Typically, coverage tool that will focus on one language or one technology. Typically, Jacoco is a coverage tool that can compute coverage for all JVM-based language, so Java, Kotlin, Ruby, Scala. But most of the time, you will have coverage tools or unit test tools for the different pieces of your project. So in SonarQube, you can aggregate the overall coverage of the different pieces, and you will not have separate report in different format for the different pieces of your project. So how do you manage that? But very simple. So here it's a project that is composed of different languages. And indeed, on the JavaScript part, I did no coverage. So I know that my code coverage is 0%. And because of those 9 lines of uncovered code, I can see that my overall coverage, no, I'm not on the right branch, web coverage, overall code. My overall code coverage is 43%. And sometimes people get confused by that because total the project has 14 lines of code, 5 lines of Java that are extremely well covered, so probably 100% of code coverage on the Java part. But in my case, 9 lines of JavaScript that has 0% code coverage, and therefore I have in SonarQube the true picture of my overall project coverage, which is just average with just below 44%. So now I know that I should also write unit tests for the JavaScript part. And as soon as I do that, I will see that my true coverage over the entire project has increased a lot. All right, I think that's it for the demo. Now I go back to the slides and add a few additions. So how do I feed into SonarQube my coverage result? There's unfortunately not one single way to do that, because actually SonarQube will adapt to the test tool format or report format that's generated by the different tools. The general pattern that we try to follow is sonar.language.test.report_pass for the test report, and sonar.language.coverage.reports_pass for the coverage report. But for historical reasons and for technical reasons, there's plenty of variation for that, and you will have to look at the documentation on what it is, depending on the language. So for example, for Python, we more or less follow the general pattern, but for Java, not so much. Why is that? Because typically, Jacoco, which is the coverage tool, is not exclusive to Java. So sonar.java.jacoco would not make sense. It also applies to Kotlin, Scala, etc. And JUnit is more than Java, so it's not specifically on Java. There are also a few languages where we don't have yet unit test report import capabilities, like JavaScript. Again, in SonarQube and generally for quality, from a quality perspective, the result of the coverage is way more important, brings way more value to the development teams than the unit test results. And that's why our first focus in Sonar is on the coverage. So sometimes we are a little bit behind on test reports. Another good example is C# or .NET. So generally speaking, when for a particular language, there's a de facto standard for unit test, we follow that format. But for languages like C#, sometimes there's no clear dominant test tool or coverage tool. So in general, we do the efforts to support many, and as you can see here, there's three test report format that we support: VS Test, NUnit, and XUnit, and the three coverage report format: VS Coverage, .cover, and OpenCover. More for PHP, for Go, I don't think I will go for everything. And more, you will have to look at our documentation. It's well documented. What is the Sonar scanner configuration parameter that you will have to set to point at the test report produced by your test tool in the particular language that you are working on. So I gave all the possible formats that are supported out of the box by Sonar, but sometimes you may work with a tool that is not part of the list, or the report that is generated by this tool is not supported out of the box. In that case, there's still some hope. We have a generic format, and in any way, a unit test report or a coverage report semantically always carry the same information. So whatever your test tool will produce, normally you are capable of transforming it into the Sonar generic format, which is the final solution if you don't have anything else to do. So the way it works is that from your test, you run your test tools and your coverage tool that generates a report in a format that's not natively supported by SonarQube. Then you would have to do a little bit of integration and write conversion script. In general, that's relatively easy to do. A conversion script into the Sonar generic test report format and coverage format. And those files that are generated, you will pass them in the sonar.testExecutionReportPath or sonar.CoverageReportPath property that is the solution to feed coverage in SonarQube when you're using, let's say, unconventional tool. I already mentioned that, so I will look at it very quickly. But yes, every time you have a statement in the code, so it can be for loop, if loop, anywhere there's a Boolean expression, this defines several branches of execution or even more conditions. And in SonarQube, provided that your coverage tool is generating the information about it, we will factor everything into it so that you see that if you have tested all the possible case of execution in your code. In terms of coverage, we spoke about unit tests, line coverage, condition coverage, but what about statement coverage, MCDC coverage, function coverage? Maybe you heard about those words in the past. All this is currently not supported in SonarQube because statement coverage, we believe that it's a little bit overlapping with line coverage. And MCDC is really for a niche. It's not excluded that at some point it's going to be covered, but this is really something that we see most of the time in the aerospace world. It's a little bit on a niche market. Okay. Also, you may wonder, okay, what if that's an example here in the screenshot. This is an example of a report generated by Jacoco directly in the pipeline. It's an HTML file where you have the information about statement coverage. This information will not be imported in SonarQube. I already showed it during the demo, but really quickly, be careful between three different metrics in SonarQube that are fairly indifferent in terms of number. The number of lines in a particular file, so it's the number of carriage returns. The number of lines of code, which are all the lines that do not contain exclusively comments or blank lines. So in that particular case, there's 14 lines, but only 9 lines of code. And in general, even much less lines to cover. In that particular case, only 5. And the coverage is only computed on the lines to cover. And all those metrics are available in SonarQube. In a large project, it's not unusual that the number of lines of code is around 30% less than the total number of lines. By the way, that's what is used for the license calculation. But the lines to cover is also a significant lower number than the lines of code, typically another 30 to to 50% less than the lines of code. Okay. So I showed in my example that I have a project which was composed of multiple languages. In that particular cases, I had JavaScript with 0 lines of code. So it was truly producing an overall coverage that was lower than on the Java exclusively. What should I do if I want to? I have unit tests for the Java part, for the JavaScript part, and I give this example, but that's valid with any other language. What should I do if I want to compute the coverage of everything, and I have unit tests for every part? Then simply you will have to combine the parameters or the properties of each separate piece of your unit test execution and pass the result of each test report separately, like you see here. Sonar.unit.report pass, sonar.coverage.jacoco for the Java part, and sonar.javascript.lcov.report part for the JavaScript part. And SonarQube, in that case, will compute the overall coverage. It's often also desirable to exclude languages that are still worth analyzing with SonarQube to detect code smells or different types of improper coding standards, like HTML and CSS in that particular case, to exclude them from the coverage calculation, because to my knowledge, there's never any coverage information for those languages. So if you keep them in the calculation, they will be counted at 0 coverage by default, and they will negatively affect, and I would say negatively and unfairly affect the true coverage of your project. Okay, I think this one is not necessary. You understood. Very often customers are surprised because they have the native report of their test, and it reports something higher in terms of coverage that is reported in SonarQube. There's always a reason for that. In general, there's no bug in SonarQube. I've never seen that before. The reasons are typically because SonarQube can see a larger file set than the coverage tool, because we have explored more directories and we found files that were not factored into the coverage report. So we count them in the calculation, and generally, if there's no coverage, we count them at 0. And also sometimes, like the HTML or CSS example, there are files that have legitimately no coverage, and if you don't exclude them from the calculation, they will be counted at 0 coverage, and therefore will bring down your coverage unfairly. Okay, but there's generally speaking, there's always a reason for that, and by tuning the right parameter, you should get exactly the same numbers. That's an example of discrepancy. The same project where I had this person.js file with 9 lines uncovered. My Java part is covered at 100%, just like Jacoco was reporting. So that's correct. But the overall coverage reported in SonarQube is only 35.7%, because the 9 lines covered at 0% are bringing down significantly the coverage. So either I should exclude the JavaScript from the calculation and I would land on 100, or I should also write coverage for JavaScript to compute to have a good overall coverage in my project. One of the last things I wanted to mention is rules for test. Not only tests that produce coverage, but they should also be written in a proper manner. And sometimes you may not write tests properly. For example, one very typical bad practice is to have a test that makes no assertion, that does not verify a result. So if you just call the function and not make sure that the function returns the expected value or behaves as expected, then your test is not very well written. And SonarQube provides some help about that. Not only we analyze the production code, but we also analyze the test code. And whenever a test is written with bad practice, you have rules to detect that. As you can see by the test-related rules in SonarQube are shown or tagged with the test tag, so you can find them easily. And at the moment I took the screenshot, there were 107 rules across all languages related to test. Okay, let's finish with a customer example. Two key examples. The first one, Tango Software. They just by integrating with SonarQube and getting all the insights on where the coverage was insufficient, etc., factored with usage of AI code generation tool, which was producing more and more code that required more tests, they were quickly able to bring their coverage from 20% to 60%. And really, it's part, of course, there's the effort of writing tests that is currently not done by SonarQube, but pointing at where you can put your effort to increase your coverage, what are the code you should focus on, is a great asset. A second example is CleverTap. They went a little bit further compared to Tango, maybe, because Tango probably they looked at everything I showed you in the UI to identify the areas that were not covered and write more tests. CleverTap went a little bit further because they integrated a certain level of code coverage in their quality gate. So you may say, okay, if I'm at 40% and I target 70% of coverage, it will be difficult for me. There will be a long time during which I will be in between those 2%, and because of that, I will fail the quality gate. But with the clean as you code methodology, you may say, okay, you are where you are, but on all the new code, you should reach at least 70% or even higher, 80%. And therefore, the tests that you write progressively are only on the new code. So you develop and you write the test at the same time. And mechanically, this will incur an increase of your overall coverage. Consistently passing the quality gate on the new code at 70 will bring the total code coverage at a higher level in the end. And that's it. Robert, I will let you proceed with the...
Yeah. Oh, yeah. Thank you so much, Olivier and Anirban. I loved all the great details you covered. I especially like how SonarQube clearly shows which lines are covered by test cases and which aren't. So I know where to focus my attention to increase my coverage. I think that's really visually, I think that's really neat how easy it is to figure that out. Before we move on to the Q&A session, I'd like to remind everyone to submit your questions in the Q&A box, not in the chat area. And as we gather your questions, I want to share about this upcoming webinar that's going to be run by me. I look better in the picture. Yeah, so it's about AI code assurance and how do you maintain a very, very high quality of code health with code assurance to make sure that when you're using AI coding assistants, you can use SonarQube to to check all the AI generated code and maintain a very high level of code health with SonarQube, with our tools. So I hope you'll join us on April 9th, and I'll get to tell you all about AI code assurance, which is, I think, an excellent tool. Okay, what's next? Oh, I think we're going to send, if we didn't already, a link to sign up in the chat box. And also, while you're asking questions, we have another quick poll, I believe. Yeah, there goes the poll. Yeah, take a second to respond. We'll let stuff come in there. Okay, we'll just let it go for a bit, and we'll move on to the Q&A session. But before we start getting to your questions, I want to make sure that you remember that if we don't get to your question in the live, or if we didn't get to it in the Q&A area, we will follow up with your questions and answers in a post in our community. So take a look at our community. It's a great resource, and look for that post when we get it. All right, when we post it. All right, we have a lot of questions. Let's get started. Our first here is from Greg. Greg asks, developers are concerned about force coverage of a high percentage for new code. As often in our age code base that doesn't have any testing in it, a simple change might impact a lot of coverage requirements. How do you deal with this? Anirban or Olivier?
Oh, I thought Daniel would answer. Yeah, so and I think
He
it
can
was
join in and help answer too. Yeah.
yeah. There's a second question I think in the chat that is related to the same topic. On this, the answer is Greg, is to have quality gates that not necessarily a single quality gate, but a quality gate that's tailored for project in those profiles. You may require you may have a second quality gate where, for instance, you don't expect 80% of code coverage on the new code, but you would create a quality gate for a legacy project where you only expect a lower percentage of code coverage, maybe 50%, or you name it. It's up to you to find where is the right threshold, still maintaining a decent quality. Okay, but you don't have to be forced on a high level coverage for all your project. You have to set the bar in a quality gate. You always have to set the bar at let's say a little bit challenging level so that developers always strive to do a little bit better, but nothing that's unreachable. Otherwise, they are no longer interested in trying to pass a quality gate. So typically you would do, okay, instead of 80%, which is the standard, I will ask 50% or 40 or something more reasonable.
Olivier, I imagine another thing that could help here is the clean as you code methodology, which allows teams to focus specifically on code that they're touching for any code change they're doing, even if it's legacy code, if they have to go in and fix something, just focusing there and focusing coverage efforts there over time will have additive effects as they gradually increase coverage, right?
Yeah. But Greg, specific question was on even expecting high coverage on new code for legacy project is not always easy.
Absolutely.
So in that
Yep.
case, you can set a lower bar even on the new code.
Yep. Absolutely.
Jonas asked, for those of us who want to add code coverage to our build process, is there a sample project or a POM file that we can use to add the needed plugins and properties?
No, not really, because it really depends on the typology. But you said POM, so probably it means you are a Java Maven. That already narrows down the combination. I think you can find some on the internet. You may also have examples in sample repositories. Check with the resource that are associated to this that were sent in the chat regarding that. I know that in our community, there's several guides related to code coverage, and I hope that you will find what you're looking for, Jonas.
Okay, let's see. I think you guys said this, but I think this is similar to the clean as you code approach. It's and that question asked, we're a fairly new organization with little to no code coverage, but we also have an older code base that we inherited. What's a good method to get started? How do I increase coverage without bringing development to a crawl?
Yeah, Anirban mentioned it, and really here it's the clean as you code methodology. In SonarQube, we will distinguish the coverage specifically, but it applies to all the metrics on the overall code and on the new code. And the general principle to not drown the development teams under a burden that's completely unmanageable is to focus on the new code. So you will say, okay, my legacy is what it is. You have 0% code coverage across the board. But now on all the new code, I expect a certain level of code. And if I have a project with 1 million line of code, an effort to reach 10% would mean 100,000 lines of code, which is a lot of effort. But so I won't look at this, but I will look at the code that I add. If I add 100 lines of code, I need to focus maybe At the beginning, my objective would be 50%, so 50 lines. That's completely manageable, and that's a little bit of incremental effort for the developer every time they write a piece of code, and they don't have to worry about the enormous burden of the legacy. And this will mechanically grow the legacy code coverage, but only progressively over time, and will not kill the developers' bandwidth.
Yeah, absolutely. And by the way, kind of tangential to this, one thing that often happens is that SonarQube isn't actually looking at the quality of unit test code because it's just different. But we actually have started to introduce rules within SonarQube that look at the quality of unit test code as well as your core code. So it's not across the board yet. It's only in a few places, but it is an interesting tool for you guys to take advantage of if you want to make sure that your testing code is as high quality as the code that your mainline code that you're developing.
I think we have time for maybe one more quick question. And Ahmed asks, if I don't include code coverage in Sonar analysis, but I have code coverage in the quality gate, is the quality gate going to fail?
Yes. Yes. So if you have if you don't intend to do coverage immediately or for a fraction of your project, you should have a quality gate that exclude the criteria on the coverage. Otherwise, you will systematically fail it. And when you systematically fail something, people won't pay attention to it anymore. So yeah, the answer is yes. And the answer should be also, you should have a second quality gate without coverage that's assigned to project where there's no unit tests.
Okay, I think we're going to have to wrap it up. We are running out of time. Thank you, Olivier and Anirban, and a huge thank you to everybody who posed questions. I'm sorry we didn't get to all of them, but again, we will make a post in community with your questions and all of our answers. So we will get to your answers, and so you'll get to see those. And also, if you missed any resources in the chat, we'll post those as well. Anyway, if you have further questions, the Sonar community is a great place to go. You'll see lots of questions and answers there, and we have a very knowledgeable developer relations team that are following up. So head over there, and if you have further questions, and don't forget, as we close this webinar, we'll have a quick survey for you. Thank you for your feedback. It's helpful for us to plan our topics in the future, and again, thank you, and see you at the next webinar. Bye,
Thank
everyone.
you. Thanks, everybody.